peak natural, CF10 and CF30. What is the difference between them? Is the difference similar like with the consumer filaments? Let's find out. Hello, welcome to my tech farm. A few months ago I had that video where I compared the peak versus PPSCF, the strongest industrial versus strongest consumer filament. And for the peak I used 3D printing services, and it looks like they're not really prepared correctly. They have very weak layer adhesion, and according to the comments, experienced viewers, according to the color, it was not annealed correctly. I contacted their online support and they told me that object should be ready for use. Anyway, since that, many companies contacted me that they can print properly this peak for me, and I chose the first two. The first one is from Europe, from Germany, and the other is from the United States, the Vision Miner. They also offer that they will print these materials for me. And this is not a sponsored video. I got these test objects for free, but I'm not paid to create this video. And please don't even send me new offers. These two, and I will close this topic. All test objects are printed by Kevin from Germany, and their 3D printing service will be available in April 2025 on these two printer types. And these test objects are printed on Apium P400, which is specialized on peak printing, but also other technical materials too. And these are those three materials from this video: peak natural, and then reinforced with carbon fibers. I believe this is the percentage, and CF30, this is bigger amount of the carbon fibers. And look at these temperatures, so definitely not printable on consumer 3D printers. Now about these chamber temperatures, I thought that peak requires higher temperatures, but because of the zone heater, this may be enough, I'm not really sure. And drying in all three cases was 90 degrees Celsius for 20 hours. And pay attention to these prices. And about the printability, something we know from the consumer filaments, the peak natural, this is hardest for the printing because of the warping on larger parts and overheating for smaller parts. And CF10, the fibers make it easier for printing with some very minimal warping. And CF30, easiest for printing because of the bigger amount of the fibers. Now I'm very curious about the difference in layer adhesion between these three materials. And now about that annealing during the printing. So the Apium printers produce fully crystallized components. No post-processing is required. And during the printing process, so-called zone heater slows down the cooling curve of the material, and the crystallization process takes place during the printing. And no uncontrolled deformations because of the volume change, so this means probably we should have more accurate parts. Let's take a closer look of the package. Beside these objects I got this print report. Look at this. This is the bed temperature, the chamber temperature, print report. So this printer is completely different level which we used to with the consumer 3D printers. So these three are those materials. This is the natural, this is the CF10, and this is CF30 filament. I also got piece of filament. Let's see how brittle are these materials. This is the natural. Not brittle at all, as expected. CF10. More brittle. Oh, piece of it flied away. These are exactly the same test objects like from that peak versus PPSCF video, printed with 3 walls and 100% infill. Let's check the shrinking. This test object is for the bending test, and I'm measuring above the elephant foot, but basically don't have elephant foot. 79.36. 80.08, 80.24, little bit bigger, interesting. Just in case, CF30 parts I marked with this white line, and they're ready for mechanical testing. Grip test the deformation under a constant load of 1.25 kilograms. $14.67, 12.21, 12.10. From these three, biggest initial deformation is on a natural material, and two carbon fibers are really stiff, very minimal deformation on both of them. This is the last 5th day, and I already measured them, and only on a natural I could notice some creeping on first 4 days. Let's remove the rod. And now let's analyze the numbers. On this graph we can see the distance between two reference surfaces, and yes, with the natural we can see some bigger initial deformation, and the two carbon fiber versions are very stiff materials. But with the creeping, what is important is the difference between 2 days, and that's what can be seen on this graph. And here, yes, with the natural I could record some minimal creeping in first 4 days, but these are extremely small values. With the carbon fiber versions I couldn't record any changes. This is some inaccuracy in the measuring. So in all 3 cases there is good to the creeping. And now the impact test with half kilogram hammer, natural peak, 0 position, CF10, CF30. 0 position of the hammer, the position after breaking the peak natural, after CF10 and after CF30. And using this equation I can calculate the breaking energy. From these 3, the toughest is the natural peak, but all 3 are quite brittle materials, not like PLA or PETG, but still on the brittle side. 3-point bending test, where I will place these loads one by one, and I'm measuring the deformation after 1, 30 and 60 seconds. This is under 1.25 kilograms, under 2.5 kilograms. And pay attention to the third one, CF30, very minimal deformation, even under 10 kilograms, which we can see now. Very stiff material. And after these tests I couldn't see any permanent deformation on them. Smaller numbers are better, so the best in this test was the CF30 and the worst the natural. With the natural peak we can see even some additional deformation under 10 kilograms during the time, so this starts to be too big load for this material, but the other 2 carbon fiber versions are very stiff materials, especially this one, CF30. The tensile test with horizontally printed test objects, and I'm starting with the natural. And on the left side you can see the average number and compare it to other materials. CF10 and CF30. Exactly what I expected. Peak performed extremely good in this tensile test, even the natural was very strong too. Layer adhesion with vertically printed objects. CF10, CF30. This layer adhesion was quite disappointing. Looks like the peak is very hard for printing, maybe because these are too small objects, because this printer have that zone heater which remelts the top layer, and this should result much stronger layer adhesion. According to their website, we should have isotropic strength here, which is very similar in all 3 axes. The hook test, where the object is exposed to the tensile and mostly the bending stress, but I will bend it until it doesn't break. I'm starting with natural, CF10 and CF30. Definitely much stronger than the average material in this test. Only confusing thing was that the CF10 was the weakest between these 3. I thought that it would be somewhere between. And when I have some confusing results, I'm reprinting the test objects, but here this was printed for me, so I have to stop here. And one more time our results, without any additional comments. At this moment I'm not really sure if I want to add these 3 lines to that summary table for my pattern supporters. I will wait for the objects from the Vision Miner, and if the result will be similar, then that's it, and I will add these lines. Now some conclusions. On one side it is very strong material in the creep tensile bending test, but somehow I cannot really like any filament which has weak layer adhesion. These 20 kilograms are on the edge of the acceptable, but especially from this filament I was expecting more because of the zone heater and remelting of the top layer. I will see if the Vision Miner will have similar layer adhesion. If yes, then that's it, possibility of the peak. But don't forget that actually peak is used in other applications too. I'm testing only mechanical properties, but I got the comments that, for example, peak has other advantages. It is used very commonly in medical applications because it doesn't irritate the skin, for example. I'm not doing the temperature test with these materials because what we would see that my oven would heat to the maximal temperature, I will open it and knock on them and they will be completely hard without any deformation. So I'm not able to do this high temperature testing with these materials. I already mentioned that there will be one more similar video, objects printed by Vision Miner from US. And if you want to get notifications about that upload, I would highly recommend you to enable that notification bell button too, because from some reason my videos are not really recommended by YouTube algorithm. Yes, my main motivations are my Patreon supporters, and big thanks to them, and that's independent from number of the views. But I'm always sad when I see that this kind of big work will stuck on, I don't know, 5, 6, 7,000 views compared to the number of the subscribers. I mean, if you watch other channels, I think it should deserve a little bit more views. I hope once at the YouTube somebody will start with the 3D printing and maybe they will find some value in my videos. Anyway, thank you for watching this one, and see you in my next video. Bye.